Hello, Advanced Algebra 2 students. This is Coach DePaulo, and this is one of the first videos I've actually recorded 2024-2025 school year. Most of the videos we've been using this year have been recorded last year. However, I've changed the lesson just a little bit this year, just enough to need a new video. So this will be the video for lesson 6.6, and we're going to be talking about the factor theorem, and we're going to be talking about different types of polynomials that we can factor. The first thing I'd like to do is take a look at this list, and if you look at number 1, you can recognize that that might not be factorable, but we know how to try to factor it, and that would be using guess and check. All right, and then the second one, that's got two terms that are both perfect squares with a minus sign in between. So this was a dots. The next one was 4 terms, and we know how to factor that 4 terms using grouping. Number 4, we know how to factor that. We just learned that in lesson 6.5. And this will be a sum of 2 cubes. And then, of course, if I took that minus away took that plus away and added a minus sign, that'd be a difference of 2 cubes. All right, and then number 5, we know that's a quartic, but it's got 3 terms. It's missing the x cubed term, and it's missing the x term. So this is another guess and check situation. Now, the number 6, if it looked like this, 3x to the 5th plus 4x to the 4th plus 12x cubed, I could factor out an x cubed using the distributive property, which we know how to do, and then I'd be left with another guess and check situation. However, if I take away that information, I'm just left with 3x to the 5th plus 4x plus 2. We don't know how to factor that one yet, and that's what today's lesson's about. At the end of today's lesson, you will be able to at least have a process to factor any polynomial. So let's go ahead and get started, okay? And so the main theorem that we're going to be using today, there are more than one that we're using today, but one of the main theorem is the factor theorem. And the factor theorem states that this binomial, x minus a, is a factor of a polynomial, which we'll call f of x, if you take this a, you plug it in here into the function, and when you solve the function, you get 0. That's very similar to what we've been doing. Right now, all we know how to do is to take a polynomial, divide by the binomial using synthetic or long division, and if we get a 0 remainder, then we say that this is a factor. So let's practice that real quick. So here, this binomial x plus 8 would give me a negative 8 that I'm dividing by. And then this will be 1 and 3 and negative 40. I'm going to bring down the 1, and negative 8 times 1 is negative 8. I'm going to add that up and get negative 5. Negative 8 times negative 5 is 40. I'm going to add that up and get 0. So we can see that 8x plus 8 is a factor of x squared plus 3x minus 40, and the quotient is x minus 5. Now, what the factor theorem is saying, instead of doing the division, just plug negative 8 in for x. So negative 8 squared plus 3 times negative 8 minus 40. Of course, this is 64, this is negative 24, and this is negative 40. And sure enough, f of negative 8 is equal to 0. So I have proven that negative 8 is a solution. Therefore, x plus 8 is a factor. Now, I've put a black box around the material that's right there because I forgot to take it out when I updated these notes, so we're not going to use it anymore. Okay, so the difference between today's notes and in the past is, in the past I've been asking you, is x plus 8 a factor? And then you would divide it into that polynomial and you'd find out. What I'm going to be saying today is, what are the what are the factors of this polynomial right here? Now, the first thing you might do is you might look at it and go, oh, there's 4 terms, I'm going to use grouping. However, if we were to use grouping, we would find out very fast that it didn't work, because I would take out an x squared and I'd get x plus 1, and then over here I would take out a negative 2, and then I would have 5x plus 4, and this one are definitely not the same. So, but here I'm not telling you what binomial to divide by. So I've got to come up with some lists on my own. Right now, all I know how to do is just start plugging numbers in for x and just hoping I'd get one right. But the next theorem I'm going to talk about today is actually called the rational root theorem. Now, it's really a corollary of the factor theorem, so most of the time teachers don't actually write out the name of the theorem. We'll talk about it, but we won't write it out. So what this is saying is, let's see, if we're looking at this polynomial right here, so let me move it up here so we can talk about it. X cubed plus x squared minus 10x plus 8. The rational root theorem says that if I take all of the plus and minus factors of the constant, which in this case is 8, and then I divide all of those factors by the plus and minus factors of q, which is the leading coefficient, which in this case would be 1. If I took those and created fractions of p over q, then those would be the only possible zeros that were rational. Now, there could be some some irrational numbers like square roots, but these would be the only possibilities for rational numbers. So I'm going to do number 1 here. I've already done number 2. I've got it covered up right there. After we're done with number 1, then you'll go over and try to do number 2 on your own, and then you'll come back and see if you got what I got. So first up, step number 1, what we're going to do is we're going to find all the values of p, which in this case are 8, and it's plus and minus. So 1 and negative 1 go into 8. And then that other factors would be 8 and negative 8. Then I've got 2 and negative 2 and 4 and negative 4. So those are all the factors of 8. Next, I'm going to find the factors of q, which since q is a 1, then it's just 1 and negative 1. Now, before I forget, understand that we are going to be using all of this space. So don't write too big because we've got a lot of work to do. Lastly, in step 1, we're going to find all of the fractions. So I'm going to take 1 and divide it by 1 and get 1. And then I'm going to take negative 1 divided by 1, and I'm going to get negative 1. And then I'm going to take 8 and divide it by 1, and I'm going to get 8. And hopefully you can see now that whenever I divide by 1, I'm just going to get the same thing. So I'm just going to go ahead and rewrite the rest of this list. Okay, so now let's start dividing by negative 1. 1 divided by negative 1. Oops, that's negative 1. I already got one of those. Negative 1 divided by negative 1 is positive 1. Oop, I already got one of those. 8 divided by negative 1 is negative 8, and I got one of those. And hopefully by now you can see that I've already divided by 1 and negative 1, and they're all going to be the same. So these are all of my possible rational roots. Step number 2, we're going to take advantage of the factor theorem, and we're just going to start off and pick one. So let's see. Let's pick, say, 2. Okay, so if I pick 2, I'm going to go 2 cubed plus 2 squared minus 10 times 2 plus 8. So that's going to be 8 plus 4 is 12. 12 minus 20 is negative 8. And negative 8 plus 8 is 0. Wow, that was pretty lucky. So I've got my first rational root. My first rational root is 0, which means my first factor is x minus 2. Okay, next up, step 3. I'm now going to synthetically divide by 2 so I can find out what the polynomial after I divide it by 2 is, because then I can factor what's left over. Bring down the 1. This is 2. 1 plus 2 is 3. And then 2 times 3 is 6. Negative 10 plus 6 is negative 4. And 2 times negative 4 is negative 8. And that adds up to 0. So this is x squared plus 3x minus 4. Then in step 4, we're going to factor that. So I've got x and x. I need a positive 3, so I'm going to put plus 4 minus 1. And then in step 5, you're just going to list all the factors, x plus 4, x minus 1, and x minus 2. Okay, now, understand the biggest mistake, or the most frequent mistake, is I divided by 2, I got my 0, so 2 is a solution. But remember, whenever we synthetically divide, if we divided by 2, that must meant the factor was x minus 2. Okay, so now what I want you to do is I want you to go over to example number 2. I want you to pause the video. I want you to then do number 2. When we come back, I'll get this yellow circle away and we'll see if you got it right. All right, let's see how you did. So the first thing you need to do is you need to define P, which were all the factors of 30. And I went ahead and put Q right there as well because I was making sure I had enough room. So Q was 1 and negative 1. And then, of course, P over Q gave you that same list of numbers. Okay, so next, you need to define an f of that gave you a 0. I happened to find it right away, mainly because I've done the notes a few times already. So it might have taken you 2 or 3 times, but I found one at 5. And then I synthetically divided, and I ended up getting x squared plus x minus 6. And then I factored that and got x plus 3 and x minus 2. So the 3 factors are x plus 3, x minus 2, and x minus 5. All right, we're going to go and do one more example, okay, on the back, and that'll be the end of today's portion of the notes, and we'll come back and do another portion of these notes tomorrow. So I've done number 4 already, and we'll find out that answer here in a minute. Next thing up I'm going to do is I'm going to do number 3 with you, okay? So the only thing I wanted to do this one for is what do we do when we have a number other than 1 right here? So let's see how that affects things. So step number 1 again, I'm going to find P, which now normally I do my factors in order, of ascending order, so I'm going to do that this time. So 1 and negative 1, 2 and negative 2, 3 and negative 3, 6 and negative 6. So those are the 8 factors of 6. All right, and then Q, this time, instead of just 1 and negative 1, we also get 2 and negative 2. So now I'm going to have some fractions. So here we go. First, hopefully you recognize that when I take all of these and I divide by 1, I'm just going to get all of these again. So that's 1, -1, 2, -2, 3, -3, 6, -6. Same thing when I divide by -1, I'm just going to get all these again. So this list is good for 1 and -1. Now let's start dividing by 2. So I've got 1 divided by 2, that's a half. And then I've got -1 divided by 2, that's a -half. Then I've got 2 divided by 2, well that's 1, I already have that in my list. And then -2 divided by 2, that's -1, I've already got that in my list. Okay, so now I've got 3 divided by 2, that'll be 3 over 2. And then I've got -3 divided by 2, that's -3 over 2. Then I've got 6 divided by 2, which is 3. I've already got that. And -6 divided by 2, that's -3. I've already got that. And then if you were to go back and divide these by -2, you would find out really quickly we've already got them. So I'll do the first couple of them so you can see. So 1 divided by -2 is -1/2. -1 divided by -2 is +1/2. So I've already got them all. Okay, so now the process is the same. Step number 2, let's find an f of. So real quickly, I'm going to just, since I haven't showed you one of these notes where I got one wrong, let's go ahead and find one that won't work. So I'm pretty sure -1 doesn't work, so let's test it. So 2 times -1 squared minus -1 squared. Oops, sorry, this should be cubed. Minus 7 times -1 plus 6. All right, and then if I go to the calculator, okay, and I type all this in. Let's see, I'm doing this on my calculator, so I know you can't see that. So I've got 2 times -1 cubed, and then I've got minus parentheses -1 squared minus 7 parentheses -1 plus 6, I get 10. Okay, so that doesn't work. So now let's go f of 1. So 2 times 1 cubed minus 1 squared minus 7 times 1 plus 6. Okay, so this is going to be 2 minus 1, and 2 minus 1 is 1. 1 minus 7 is -6, and -6 plus 6 is 0. There we go. I got my 0. All right, so what factor is that? That's going to be x minus 1 is my first factor. Step 3, I'm going to then synthetically divide by 1. I got a 2, a -1, a -7, and a 6. Bring down the 2. 1 times 2 is 2. -1 plus 2 is 1. 1 times 1 is 1. -7 plus 1 is -6. And 1 times -6 is -6. So this is 0. And just to keep my notes consistent, let me go ahead and turn these blue. There we go. All right, so now this is 2x squared plus x minus 6. Step 4, let's factor that. So I know I'm going to get 2x and x, and let's try 3 and 2. Okay, so let's see. Let's do our O and our I. So O is going to be 4x, and 3 times x is going to be 3x, and I need to get to 1. I can do that. I need a +4 and a -3. So that means I need a +2 and a -3. There we go. +2 and -3. All right, in step 5, list our factors. 2x minus 3, x plus 2, and x minus 1. Okay, now, just so you can see, Let's take this right here, this factor, 2x minus 3, and let's see what solution that gives me. So I'm going to set that equal to 0. I'm going to move the 3 over and get 3, and I'm going to divide by 2 and get 3 halves. And sure enough, had I got to the fractions, there's 3, oops, let's see. So this 3 halves, it's right there. Oops, here we go. This 3 halves was right there in my list. So I could have tested 3 halves and would have got an answer for it. All right, I want you to pause the video one more time. And really, all I need you to do, as long as you got example 2 right on your own, then all I really want you to do then is I just want you to get the P and the Q and the P over Q. And if you can do that, then I'm sure you can do the rest of this. So just go ahead and do that for me. Pause the video, try to get all the P over Q's, see what you can find, and then unpause the video and come back and check. Okay, let's see how you did. So first up, P was plus and minus 1 and 40 and 4 and 10 and 2 and 20 and 5 and 8. And Q was plus and minus 1 and 3. I saved some space because I knew it was going to be a lot, so I wrote the plus and the minus. You're more than welcome to do that as well. And look at all of those numbers. That's why I had to save some space. So I got a lot of fractions. I got a lot of numbers. So it turned out to be a really big list. All right. For me, if you want to go ahead and look and see, I got 4 and negative 4. I tried a couple others, but I had to erase. So I finally found negative 4 was a solution, divided by negative 4, and ended up getting 3x squared minus 13x minus 10, and ended up with 3x plus 2 and x minus 5. And if you notice this 3x plus 2, if I solve for x, I subtract 2 from both sides, so 3x is negative 2. So x is negative 2/3. And if you look right there, negative 2/3 was a choice. So, all right, we are going to do 5 and 6 tomorrow in the second half of these notes. So you are now done today. So if you are listening to this video, your homework for today will be 1 through 4. Hope you have a great day.